Okay, ladies and gentlemen, I know this might be a little bit hard to see. It's the best picture I could get with my iPad. So, let's see. On problem number 1, they tell you that FL is a line of symmetry, and as I noted, that just means that it cuts it in half. So it's pretty much meaning that it splits your vertex angle of the isosceles triangle in half. They gave you that LFC is 25. Now, if that line is splitting it in half, that means it's also 25 on the other side. Now, if it splits the vertex angle in half, we learned on Friday, maybe Thursday, whatever the intensive day was, that any line that splits the vertex angle of an isosceles triangle in half is a perpendicular bisector. So we know that it creates right angles at the bottom, and that it splits the bottom CT in half, so 2 equal halves on each side. So the measure of angle CFT would be the entire top together, so 25 and 25 is 50. The measurement of CF, well, if this is going to be an isosceles triangle, then that should be the same as the other side, 12. The measurement of TLF, okay, TLF I've already marked as a 90-degree angle because FL is a perpendicular bisector, so we know that's 90 degrees. And then CT, on the bottom, it's split into 2 equal halves. We've already got LT marked as 5. We know CL also has to be 5 because it's split in half. So all of CT is 10. For problem number 2, we've been given that ST is perpendicular to TV. So if it's perpendicular, that creates a 90-degree angle. We've also been given that WTV is an equilateral triangle. So all of its sides and all of its angles are equal. So if I draw a little bit bigger over here so you can see it, WVT, all of its sides and all of its angles are equal. So all of these sides are 5, and every single one of those angles is going to be 60 degrees. That's what we know. So we're going to use that information throughout this problem. STV. STV we've already marked as 90 degrees, so we might as well fill that in. WTV we've just stated as part of that isosceles triangle, so that has to be 60. TWV, again, is part of the isosceles triangle, so that's also 60 degrees. SWT, well, we'll come back to that one. Let's go on to STW for a minute. STW. If we know that STV is 90 degrees and WTV is 60, that leaves 30 degrees for STW. Okay, 90 minus the 60. Now if you look at triangle STW, look at that triangle. We've already been given that there's 30 degrees here, and now we know that STW is 30. We just solved that. Two 30-degree angles, so that means it also has to be an isosceles triangle. Well, if we want to know what SWT is, we already have 30 and 30, that's 60. Subtracting that from 180 leaves 120 for SWT. WV, we've already shown over here on the right side of the screen, is 5. WT, again, we've already shown that, it's 5. SW. Okay, since WT is 5, we know that we have these two 30-degree angles here. And so this is an isosceles triangle, which means the two sides have to be equal. So if TW is 5, then SW must also be 5. SV is made up of SW and WV. Well, SW was 5, WV was 5, so SV is 10. Alright, now problem number 3. Sorry about the pause in between. I have to find the correct photo. They gave you a bunch of equal sides over there. In triangle ABE, you have AE is equal to BE. In triangle BED, you have two sides equal, and so forth. So the first question is, an angle congruent to angle 4. Well, using that little isosceles triangle, BDC, angle 4 is opposite of the one equal side. Opposite of the other is angle 5. So angle 4 and 5 must be equal. What's angle 1 congruent to? You looking all the way to the left side of the screen, angle 1 and angle 2 would have to be equal because of the isosceles triangle theorem. Angle 9 is equal to angle 8. Part D, if ED is 5 and BE is 5, then BD also has to be 5. They're already marked as equal. CD, well, BD and CD are marked as equal. So if BD is 5, CD must be 5, which means that triangle BDE is an equilateral triangle. On to the true and false. Number 4, every equilateral triangle is an equiangular triangle. That's true. If all the sides are equal, all of the angles have to be equal. Number 5, every isosceles triangle is an equiangular triangle. That's false. Okay, it has to have 2 equal angles. It doesn't have to have 3. It can, but it doesn't have to. Number 6, the line of symmetry for an isosceles triangle divides the triangle into 2 right angles. We know that that's true because if it divides the vertex angle in half, it's a perpendicular bisector, so it creates those right angles. Number 7, if 2 angles of a triangle are congruent, the triangle may be scalene. That's false. Scalene means that all the sides were different, so that would mean that all of the angles have to be different. So there's no way to have 2 that are equal. Okay, on to the proofs. Problem number 7. Let's see here. So the first thing that you want to do is start with your given. Angle 3 is congruent to angle 4. So we know this one and this one are equal. Now we want to get AB equal to BC. So we need to get from the angles to the sides. And the only thing that allows us to switch between angles and sides is the isosceles triangle theorem. But we don't have the correct angles in this one in order to be able to do that. So we need to get from angle 3 and angle 4 to angle 1 and angle 2. So let's relate angle 3 and angle 4 to angle 1 and angle 2. Well, what I know is that angle 3 and angle 4 make 180. And I'm sorry, angle 3 and angle 1 make 180. I wrote it but didn't say it. Angle 2 and angle 4 is also 180. And we know that because they're a linear pair. Okay, remember, linear pairs are any 2 angles that form a straight line, and they always add up to 180. Since angle 3 plus angle 1 equals 180, and angle 2 plus angle 4 equals 180, I can take angle 2 and angle 4 and substitute that in for the 180 because they're equal, which is going to give me the new equation, angle 3 plus angle 1 equals angle 2 plus angle 4. And again, substitution property. So now we know that angle 1 and angle 2, we want to get to angle 1 and angle 2 are equal, but we know that angle 3 and angle 1 add up to angle 2 and angle 4. So all we need to do is get rid of the 3 and the 4. Well, since up here we know that they're equal, I can subtract angle 3 from one side and angle 4 from the other, and it will still be a balanced equation. So if I get rid of angle 3 from the left side, I have angle 1, and if I get rid of angle 4 from the right side, I'm left with angle 2. I did that, I got rid of them by subtracting. So that's the subtraction property. Now we're down to angle 1 and angle 2. So we can switch over to the sides. Opposite of angle 1 is side BC, and opposite of angle 2 is side AB. So those two sides have to be equal because of the isosceles triangle theorem. Alright, last proof that you had for homework the other night, problem number 21. So we had, this one was a fill in the blank proof. So the first one, I'm betting you probably were able to get, is given. The second one, they switched from sides to angles. That's the isosceles triangle theorem. The third one, they had all these different things that were equal, and they kind of just linked them end to end. This angle B linked up with this angle B, and angle C here linked up with this angle C. So that's the transitive property. Now having that angle A equals angle B equals angle C, they know that angle A, B, and C have to add up to 180 because of the triangle sum theorem. Every triangle adds up to 180. We learned that earlier in the year, but we didn't really use it in a proof because we didn't have a purpose for it. This is really where that purpose kind of starts to fall into place. So the triangle sum theorem is anytime you want to add the three angles together to 180. Now if angle A plus angle B plus angle C equals 180, I can substitute A for B because I know that they're equal, and I can also substitute A for C because I know that those are equal, leaving me with 3 of angle A equals 180. So that's substitution for step number 5. Number 6, if 3 angle A equals 180, I can divide by 3. So that's our division property, which leaves us with angle A equals 60. The last step there, since angle A is equal to 60, all they had to do was use that with the transitive property from above for another transitive property, which gives us that all of those have to be 60 degrees. So they ended up using the transitive property twice.